Hello folks, Prasad Domla here, and in this video I'll show you how to set up local development environment using AWS SAM CLI or Serverless Application Model CLI. So let's get started. So before SAM CLI, normally we would create, update and test our Lambda functions directly on AWS Management Console. It's okay to use this process if you quickly wanted to test something, but the idea of having your production code on an online editor does not sound good in this era of infrastructure as code, where everything is codified and version controlled. Another reason for me to have a local Lambda development environment is that I can use awesome code editors like VS Code instead of some basic online code editor. Now, when we talk about serverless, we often hear serverless applications and serverless functions. So basically, serverless function or a Lambda function is a piece of code you write and deploy to AWS, which gets triggered by various events. A serverless application can contain one or more Lambda functions, and additionally, it can contain various other services as well. Most commonly, API gateways, DynamoDB tables, or SNS topics, and so on. So what is SAM or Serverless Application Model? So SAM is a framework which will help you to define your serverless application resources like Lambda functions, API gateways, and so on. Basically, it is kind of a simplified version or extension of CloudFormation templates. So this is the flow of creating and managing a serverless application using AWS SAM CLI. So I have my local repo for my serverless application called my SLS app1. So inside that folder, I have a separate folder for my Lambda function, say Lambda-1. Remember that a single serverless application can have multiple Lambda functions and other AWS resources included. Within my Lambda1 folder, I have my main.py Python script where I write my code for this particular Lambda function. So you can add all your custom modules and other Python files into this particular folder. Then we have samtemplate.yaml, which is similar to CloudFormation template with some minor differences. We'll see that in a moment. So this SAM template will be used as input to our SAM package command, which basically converts the SAM template into a CloudFormation template, which I'm calling it as SAM deploy.yaml. Apart from generating this deploy.yaml file, SAM package command also packages your Lambda code or serverless application code into zip format and uploads it to S3 bucket. And the S3 URL will be updated in your deploy.yaml file. So after packaging, you can deploy the application using the generated SAM deploy.yaml file, which basically creates a CloudFormation stack with all your Lambda functions, API gateways, and other resources you define in your SAM template. I showed only Lambda and API gateway here, but it can include other services like DynamoDB, SNS, and so on. So that is the overall process of creating and deploying your serverless application on AWS. You can also test your Lambda functions locally before packaging and deploying your application to AWS. So we'll see that later in this video. So as far as prerequisites are concerned, we need an AWS account. I hope you have that already. And then we need AWS CLI and you need Docker. So this Docker is required if you want to test your applications locally. So whenever you execute SAM local invoke commands, it will start a Docker container and test your Lambda function or API gateway on that particular Docker container. So if you are planning to do some local testing of your APIs and Lambda functions, you need to have Docker installed. And you need to install SAM CLI on your local machine. You can do it using pip, that is pip install and then -- user to install it for that particular user, and then AWS SAM CLI. Now let's jump into our demo. So I have all the prerequisites already installed. So if you check the versions, I have AWS CLI version 1.16.81, and I have my Python installed, that is 2.7, and I have my SAM installed, which is version 0.10. And then I have my Docker installed as well, which is 18.09 version. So make sure you have all these prerequisites installed. So now I am in my local directory where I wanted to create my SAM application. So we can use SAM init command, which will basically create the structure of your serverless application, the same structure we discussed earlier. So the command would be SAM init, and then you need to provide the runtime. In my case, I'm using say Python 3.7. So if you want to see all available runtimes, you can just execute SAM init help command, which will show you all the options available. As you can see, for runtime, you can use .NET, Go, Python, Ruby, Node.js, and so on. For this demo, I'll be using Python 3.7. So I'll say SAM init, and then -- runtime will be Python 3.7. And then you need to provide a name for your application, which is nothing but a directory name, the root directory name of your SAM application. So I'll just call it as my SLS app, that is my serverless app. So let me open this directory in Visual Studio Code. So I'll just say code my SLS app. So I have my new folder opened in Visual Studio Code now. As you can see, by default, it created a hello world application for us, and a sample template file, that is template.yaml. So this is our SAM template. First, let's create a new directory for our Lambda function. So for this demo, let's say we want to list all available EC2 regions. So I'll just call this as get EC2 regions. And inside that folder, I'll create a new file called as say main.py, which will be my entry point to this Lambda function. So I'll just quickly copy and paste some sample code here. So basically, I'm declaring a EC2 client here, and I'm just running EC2 client.describe regions, and I'm just returning the regions response. So nothing complicated here. Let me save this. Now we have our simple Lambda function code here. So let's go to our SAM template here. So as you can see, a SAM CLI has given us an example YAML code. It looks similar to CloudFormation template with an additional key called as transform, which basically indicates that this particular SAM templates need to be converted into a CloudFormation template before deploying it to CloudFormation. And SAM CLI will do that transformation for us. So we have global section here, where you can specify global variables applicable to all functions you define in this template. You can check SAM CLI GitHub repo for the list of all global variables. I'll leave the link in the description. So let me quickly go to that repo. So here, if you go to global section and then click on this globals guide, you can see all the available properties that you can specify under globals section. So you can add any of these properties to your SAM template. So let me just change the timeout to say 1 minute, that is 60 seconds. Under resources, you need to define all your Lambda functions. So I'll change my Lambda function name to say get EC2 regions function. And then the type would be AWS serverless function. The code URI is the root directory of your Lambda function. So in our case, it is get EC2 regions. The handler would be the file name and the function name. So here my file name is main.py. So it would be main.lambda handler. So in my main.py, the function name or the entry function name is lambda handler. So that's why the handler would be main.lambda underscore handler. So the runtime, I'll leave it as 3.7. You can specify all your environment variables here as a list. I'll just leave the default environment variables for the sake of this demo. I'll add a couple of additional properties. The first one is the function name. Again, you can find all these property names in the documentation here on GitHub. So if you go to resource types, and then if you go to function, so you can see all these property names here. So I'm adding function name and description. So if you don't add the function name, SAM will create a random function name with some random string. I don't want that. So you can specify the exact function name you want, and then you can add some description. And also I'll add a role that needs to be used for my Lambda function. Again, if you don't specify the role, Sam will create a new role for your Lambda function. So let me specify these 3 parameters in my template.yaml file. So I'll say function name as say get EC2 regions, and then I'll provide some description, say Sam demo get EC2 regions, and then I'll add a role as well. So the value for this role will be the ARN of your IAM role. So I'll just copy my ARN here. So next, under events, I'll change the name as say get EC2 regions API, and then I'll change the path to say get EC2 regions, and the method I'll leave it as a get. Apart from API type of event, you can add additional event types as well. Let me show you the list of supported events. So on the GitHub page, select this event source types. So here you can see the list of all supported event types like S3, SNS, Kinesis, DynamoDB, SQS, API, which is the one we are using in this demo. So you can use any of these event types. So these are nothing but the triggers for your Lambda function. So that's event section. And then coming to the output section, these are the outputs that you can see on your CloudFormation stack. So I'll just change this to say get EC2 regions API, and then the path would be get EC2 regions, and the function name, I'll just say get EC2 regions function. This is nothing but the ARN of your function. So I'll just copy the function name and then put it here. And we are not creating any role as part of this template, so we don't need this last output. So I'll just remove that. So that's the configuration needed in our SAM template. So we are basically defining the globals and resources, that is nothing but our Lambda functions and events for that particular Lambda function. You can add as many Lambda functions as you want under resources, and we can add all the outputs that we want on our CloudFormation stack. Now, before deploying it to AWS, we can test this Lambda function and API gateway locally. So let me open the terminal here. So we can test individual function and also simulate API gateway locally. So let's do both in this demo. First, to test the function, we can use SAM local invoke command. That would be SAM local invoke. And then you need to provide the function name, which is get EC2 regions function in our case. So let me copy that. And then we need to provide the event payload to execute the Lambda like we do on the console. So we can do that locally by creating a JSON file with required payload JSON, and specify the payload using --event option, and then your file name, file name dot whatever file name you use, file name dot JSON. But in our case, we don't need any event for this particular Lambda function. So I'll just say no event. And before executing this local invoke command, make sure your Docker is running, and also your AWS profile is set. So when you're testing your serverless applications locally, it will use the AWS profile you have set locally on your machine, not the IAM role used in your Lambda function. So make sure you have your AWS profile set with right access keys, and also start your Docker. So now we can execute this command SAM local invoke, and then your function name, and then no event. So if you're doing it for the first time, it might take some time to pull the Docker image, but I have my Docker image pulled already. So as you can see, our Lambda function executed without any errors. So the output you get here is similar to the output you see when you test your Lambda functions on the console. So you can see the build duration, memory size and memory used and so on. And you can see our actual response from the Lambda function. Now let's simulate API gateway as well. So for that you need to use a SAM local, and then the command name is start API. So it will basically start a local server on port 3000, and it will give you the URL to test your API. So you can just copy this URL here and then go to your browser and then paste it here. As you can see, we can see the response here. So this is basically, simulating your API gateway URL locally on your local host on port 3000. So you can close this process here. So that's how you can test the Lambda function and simulate API gateway before deploying it to AWS. So once you're happy with your testing, the last step is to package it and deploy to AWS. So to package the serverless application, you can use SAM package command, and then you need to provide the template file name, that is template file. In our case, it's template.yaml. And then you need to provide the output file name, which is your converted template. So that is output template file. I'll just call it as deploy.yaml. And then you need to provide S3 bucket to store your Lambda code. So I'll just provide S3-bucket. So I have a bucket already created for this demo, which is called as pdomla sam demo. I'll use the same bucket, then execute it. So as you can see, it successfully uploaded this particular zip file onto S3, and then it created our deploy.yaml file. You can see here. So we'll be using this particular YAML file to deploy our resources to CloudFormation stack. So you can either use AWS CloudFormation deploy command, or you can use SAM deploy command. Basically both are same. Let's use SAM deploy. That is SAM deploy, and then again -- template file. So in this case, the template file would be deploy.yaml, and then you need to provide stack name, stack-name. I'll just call it as my SAM stack or my SAM Lambda stack. You can give any name you want. So this will take this deploy.yaml file and it will create a CloudFormation stack. So it will take like a minute or so to deploy your CloudFormation stack and create the API gateway and Lambda functions. And one thing to notice in this deploy.yaml file is the code URI. So now it is the S3 URL instead of your local directory. So this is where your code is uploaded. So the stack creation is completed now. As you can see, successfully created or updated stack, my SAM Lambda stack. So let's go to our console and verify the resources created. So I'm on my CloudFormation console here. As you can see, we have our my SAM Lambda stack created. So if we go inside that Lambda stack and then check out the resources, you can see that our Lambda function is created, which is get EC2 regions. So let's open that and have a look. So this is our Lambda function, which is get EC2 regions, and you can see we have API gateway trigger here, and you have your Lambda code here. Next, we have our Lambda permissions, and API gateway is also created here, which is this one. You can see our resource path is created, get EC2 regions. And if you go to output section, you can see the ARN of your Lambda function and also the URL of our API gateway. So you can access this URL. Let me copy it. So you can see the response from our Lambda function. So you can add this app to our Git repo and add new functions or update existing functions. And when you are done testing locally, you can simply run SAM deploy command with existing stack name if you already have the stack created for that, to update your Lambda functions and API gateways and other resources on AWS. So that's how you can develop and test your serverless applications and functions locally and deploy them to AWS using SAM CLI. So that's it for this video. If you have any questions or suggestions, please let me know in the comment section. And I hope you found this video useful. And please do subscribe to my channel for more videos. Have a good day and see you in the next one.